Hello, everybody. This is another workshop on our November series. And this time, Christopher Small will be talking about Oz.
Hi, folks. Happy to be here today. I'm going to see if I can share my screen. Okay. All right. Let's see. Okay, cool. Is that legible for everyone?
Yeah.
Excellent. Cool. Yeah. So today I'm going to be talking about Oz, and before I kind of get into things, would just like to acknowledge the support that this project has received from the Clojure community, from Nubank and Cognitect, who've been graciously, supporting this work for several months now, as well as a number of other individuals who've been contributing on GitHub. GitHub sponsors, and so or who have also pledged to do so. So yeah, to everyone who's done this, it just makes it makes pushing this stuff forward that much easier to know that that it means that much to folks to that they're willing to support it. So thank you very much, everyone. Moving along, I should start with a disclaimer, which is to say that you will probably be seeing me break some things today, but I promise that no parentheses were harmed in the making of this presentation. So to start off with here, what is Oz's goal? Well, Oz's goal has kind of evolved over time, and it's sort of evolved into that of a Swiss Army knife. And while in a perfect world, this is sort of what you get, something that you can kind of easily look at and figure out what's what and what you can do with the tool. The it's sort of intentional. I need to scroll down here, right? Is that the risk of this is that it can be hard to even know what the thing is and what it can do, and effectively, this is sort of a marketing problem. I've had on numerous occasions, talked with folks who've used Oz in various capacities who didn't realize everything that it was sort of capable of, right? And so one of the things I've been doing recently is looking back and seeing how I've communicated changes around Oz and how I've talked about Oz, and seeing how I can try to help people get a better sense of everything that it's capable of doing, so that they can take advantage of it for their work. So doing that, my goal is to kind of trace the yellow brick road to see how Oz got here. Just kind of look back at things historically. And again, to kind of use that as a segue into like thinking about what Oz is really trying to be by looking at what it has been and how it sort of got to where it is now. And furthermore, to use that then as a segue for discussing the latest features in Oz and the sort of long-term goals and direction. So first of all, how did we get here? In the beginning, Oz was forked from Vizard, which was a very simple. Oh, got an. Hold on a second here. Oz was forked from Vizard, which is a very simple data visualization library for Clojure built around Vega Lite. Now, the author wasn't interested in supporting the full grammar of Vega, which and sorry, I need to take a step back here. So Vega and Vega Lite are data visualization languages written by some folks at the Interactive Data Laboratory here at University of Washington in Seattle. And in very broad strokes, what make these data visualization languages special is that they are pure data specifications that you use to actually program these data visualizations. So this is sort of in contrast to a lot of data visualization libraries where you're effectively writing code to do the work of creating a data visualization for you. And we as Clojurists, of course, love the idea of programming using data. code is data. It's all just data, right? I mean, this sort of the ephemeral Clojurist joke, or the eternal Clojure joke, is that it's all just data. And so Vega and Vega Lite are, again, data visualization frameworks which really fit nicely into this paradigm that we have within Clojure, and take ideas from that have played out in other data visualization libraries, such as ours, ggplot, built around the grammar of graphics, and taken that to kind of the next level with a grammar of interaction. So Vega and Vega Lite not only allow you to very declaratively describe how you map properties of your data to aesthetic attributes of a visualization, but also how you can map interactions with a visualization into aspects of a data flow, which can then feed back into what the visualization is actually showing you, and does a really amazing job at this. But sort of taking a sort of step back, again, Vizard was a library which supported Vega Lite, and sort of wrapped it for using from a Clojure REPL. So my very first goal with Oz was that I needed to do some Vega visualizations. So Vega Lite is a sort of higher level grammar in this data specification language, but compiles down to Vega, which is a lower level, somewhat more a little bit more work involved in getting a full Vega visualization, but is also a lot easier to sort of control, to fine tune, and offers some features which Vega Lite doesn't. So while Vizard was sort of happy sticking with Vega Lite, which is perfect for 95% of your data visualization and kind of data science needs, I was working on a project where I actually did need the full power of Vega for doing some particular transforms and that sort of thing. And so after discussing with the author of Vizard, he wasn't really interested in full support for Vega, and so I just went ahead and took the library and forked it. And that was sort of the beginning of this road towards Oz, where not only did I add support for Vega here, but I added support for Hiccup and Markdown, recognizing that seeing a single data visualization is great, but what if you need to see a number of data visualizations to kind of look at different aspects of a data set? And what if you wanted to combine those visualizations with other information, with text, with other content, tables maybe to present data, et cetera. This is where I started getting into, okay, maybe we can kind of expand this notion of this very data-driven Vega Lite, Vega specification with our own sort of data-driven language for describing HTML, which is Hiccup, right? And then moreover, because most of us like writing Markdown when we're writing prose, what if we could add Markdown support to that as well, so that you could embed data visualizations in your Markdown? So these are some of the kind of early goals where I realized, like, okay, this is actually kind of an interesting this is kind of interesting project where it felt like every sort of step I took opened up a new door to some new feature that I could offer the Clojure community. Another piece that came in here was taking the front end Clojure script reagent components that sort of did the work of wrapping Vega and Vega Lite, and sort of exposing them as part of the public API. Officially, there was nothing actually that I had to do other than just to say, like, okay, these are, you can go and use these now, because it wasn't really, officially stated that was going to be supported with Vizard. So, and the final thing I experimented around was some interesting features allowing you to share visualizations with people. So Vega Lite and Vega have this Vega editor online, where you can use a GitHub gist to store a visualization, and use a sort of special URL notation to load that visualization in a Vega editor. And I recognize that just a little bit of authentication with the GitHub API, that you could actually kind of automate this process. And so again, just in the beginning, thinking about small steps about how can I build a suite of tools around this basic idea of having a REPL connection to some interactive data visualization. How can I kind of build around that to make something that's more that allows you to do more, that's more robust and more capable. But things started getting a little bit more interesting once I realized that, well, we're already, again, dealing with hiccup and markdown, dealing with HTML. So why don't we consider building static HTML output, right? I mean, anyone who has, run a personal website or a blog has, or perhaps even, tried to produce a report based on some data analysis that you're doing, can recognize the value of being able to write out a static HTML file that you can take and pass around and share with people. And this was really kind of the next sort of obvious step for the project, given that, again, we were already viewing hiccup and markdown. Why don't we also add the ability to write this stuff out and make it sort of more reusable? We also did some other things like add support for Clojure, making it so that within a Clojure notebook, I guess I should clarify for those maybe not familiar, but Jupyter Notebook is a kind of more traditional data science notebook environment built in Python. And it does have sort of a kernel system, which allows you to plug in kernels for different programming languages. And there's one for Clojure called Clojupyter. Additionally, one for another one for Clojure called iClojure. And so built support for doing Vega and Vega-Lite visualizations together with Hiccup within both of these contexts. So again, very kind of natural progression or growth here as things went forward. But where things really became interesting was when I was listening to a talk by Arya then at Amperity, who, and I'm just paraphrasing here, but he was talking about the sort of state of data science in Clojure and the strengths and weaknesses. And one thing that he pointed out, which really stuck with me and got me thinking, was he asked this question. We as a Clojure community, especially those who do front-end development with Clojure Script with Reagent, have grown accustomed to a really fantastic, just top-notch development environment where we have live code reloading, we have the ability to connect a REPL into the running the running environment in the browser and interact with it just as we would with our Clojure code, and just this really incredible experience. And a state of flow that emerges from this, from Figwheel or Shadow CLGS, whatever sort of tool you use. Figwheel was the thing at the time, but this sense of flow that emerges when you have this very responsive development environment where you save a file, you can see the changes instantly. If you want to evaluate something in the REPL, you can do that instantly. That sense of flow that emerges from having that rapid feedback loop has been really pivotal in making ClojureScript or Clojure a great language for doing front-end web development. And so the question here, which Arya posed, was, what would it look like to bring that to the data science notebook world, right? And again, this was an idea which just started digging into my brain and got me thinking. And I thought would be the simplest possible implementation of this, and release this around, it looks like the day was March 26, 2019, released Oz 1.6.0 Alpha 1. And this came with the functionality that would let you build and view Clojure files. So again, building and viewing in the sense of we're loading up into a browser tab so that you can kind of dynamically look at it, but also build out to a static HTML file, and do this using Clojure files as input. And the basic idea here was to get something even kind of remotely close to this kind of live coding experience. You can't necessarily do what you do with with Figwheel or with Shadow CLJS where you're doing Clojure script, because as data scientists, we're frequently running, data intensive jobs. And so we can't assume that we can just recompute an entire file. We have to get a little bit more clever. And the simplest thing that I could think to do that would possibly, get you even a good chunk of the way there was just to simply recompute from the first changed file in, first changed form in the file. And then the basic mode of display for taking, whatever the evaluated Clojure is and turning that into a into HTML or something that you could view was to just take the final form in that file and interpret it as hiccup. This changed a little bit later, but even early on here was very simple but very effective. And I found that was able to start to kind of capture some of that flow of, say, a Figwheel or Shadow live coding experience in a kind of notebook form. This evolved. One of the key things that was realized in talking with Daniel and others in the community is that it kind of having the final form be like the hiccup form that you render was sort of computationally convenient, but didn't actually make a lot of sense as a sort of literate programming tool, which is kind of the goal of this whole kind of direction of having a live code reloading data science notebook. And so what was suggested as a way to sort of improve that was, instead of just the final form, read any vector literal in the file as hiccup. So in your code file, anything that looks like a vector literal, that's going to be interpreted as hiccup. You can have code in that vector literal be computing things kind of dynamically at build time, but as long as that outermost form is a vector literal, that will get interpreted as hiccup. But this, we're now 2 years later, and we are still in alpha, in Oz 1.6.0 alpha, I think 36 now, which is a little bit silly to say, but part of the reason why it has taken so long to take this to the next step and to, I guess these slides maybe were backwards, to get to take things to the next step and really achieve all the goals that I had in mind with the project, really have to do with kind of the nature of those goals and some of the challenges that they pose for the way that the code was sort of organized, and the way that the initial implementation evolved. So the particular goals in question here were having comments as markdown within the file. So the initial parser that I was using was just using a simple, let's see, what is it? Clojure data reader or Eden. I'm forgetting the exact namespace now, but
tools reader.
Yes, tools reader, exactly. Thank you. Which is great for reading in forms of Clojure, but strips out all of the comments and anything that would count as white space. And so that was kind of the initial challenge. The next was proper dependency tracking. And here it was sort of somewhat obvious that you could probably use something like Tools Analyzer to take care of the sort of the grunt work there, but there would still be some work in applying that thoughtfully and analyzing the code and figuring out which forms depend on which in order to do something smarter than just starting from the first changed form and recomputing everything afterwards. If I have a big expensive computation in the middle of my file, but something very incidental, maybe even just a comment, changes above that. And sorry, that is to say, not just a code comment, but something that's actually supposed to be rendered on the page. The entire thing needs to update, and that was just there were kind of some ways around it, but it just wasn't it wasn't kind of the full vision or the ideal that that we had in mind. Some other things that percolating around that don't necessarily directly have to do with why some of these complications, but which were again just further goals for kind of the next phase of things. Was evaluating code in Markdown files so that you could use the Markdown files as kind of a more proper notebook environment, just like the CLJ files, and more fine-grained control over the Clojure script or reagent components. And this being kind of more of a separate issue, but again, right, we have this Swiss Army knife, this tool that's kind of grown in a number of directions, and slowly but surely, there's a number of things which have emerged on just this view layer side of needs to make these components more sort of capable. So in the interim, we've seen a few different projects that have kind of taken inspiration from this and taken things to the next level in one way or another. Namespace made some progress in interpreting comments as Markdown, and Clerk made quite a bit of, did a great job producing an environment very similar to what Oz was trying to achieve, with some differences, and that's something something to pick into later there. Kind of interesting points of maybe philosophical difference, but really did a wonderful job in particular in solving these dependency issue problems, so that you would look for which forms had changed and only run or that is to say reevaluate forms which actually depend on them. So this was all great stuff to see, and it's been one of the really fun parts of this project to see that something that you do can kind of inspire other people to kind of take it to the next step, right? When I first threw this thing out there, it was kind of an experiment, and I had no idea if it was going to go anywhere or if anyone was going to be interested at all. So it's been really cool to see the community take it in different directions and help kind of to move the idea forward. So, sorry, just a second. So I am really happy today to announce the release of Oz 2.0.0-alpha 1. I should have, here I can actually state that. This is something that I've been working on for a few months now, and has only really within the last couple of weeks taken definite form. It's not, unfortunately, there's some kind of aspects of what I'm trying to achieve here, which I wasn't able to get done in time for this presentation. So hopefully, maybe if we on Sunday after the conference, if we do our data science day, I might be able to show some of these things. But the kind of core functionality that I was after, which is again this proper dependency tracking between forms, has now been implemented. Not only that, but it also evaluates these forms in parallel. So as I started thinking about this problem, if we recognize that a set of forms are independent of each other, is there any reason not just to compute them in parallel? And in particular, for doing a lot of these, for doing a lot of the static output, where you're rendering a bunch of data visualizations as static images, so that if a browser loads that has JavaScript turned off, or if you're trying to convert to PDF or whatever the case might be, that you actually have like real compiled images in the HTML and not just some JavaScript that will only work if you're in a JavaScript enabled environment. And so yeah, that's one of the big things that does work now. And I didn't. There's quite a bit more that should really be going on this page, but one of the other things that it's at least worth mentioning for now is just nicer layout. Really taking the styling from the initial hit of Oz and trying to make it nicer. This is all to say you've actually been looking at an Oz document right now. So this isn't this is not part of the 2.0.0 release, but one of the things I'm working on is making it so that you can have different kind of well, yeah, I guess what I should say is it's already possible to have template functions that you use to sort of lay out the content that you've compiled from whatever input sources you're working with. But this sorry, a second. I'm a little embarrassed. I lost my train of thought here. Let's see here. Where were we? Can anyone refresh my memory?
Yeah, I think you were telling us that this is actually an Oz view, and you're working on certain templates of.
Yes, thank you. Right, thank you. The templates. Yes. So yeah, so this is actually an Oz view. One of the things that I also want to do is put together a collection of templates that are kind of ready to go. What I was saying was it is already possible to set up a template with one of your build processes so that you can organize your content in a particular fashion. Yeah, one of the things that I'm hoping to do and starting to do here is put together a set of kind of pre-packaged templates for doing things like slides or documentation, code documentation, so that you could, I don't know how many of you might be familiar with Marginalia, but it was a documentation tool that was, I don't know how popular it was, some number of years ago. It's fallen into disuse a little bit. But it was really just a lovely literate programming sort of light tool that would take your source code and produce documentation with it in this kind of Marginalia format. And so that's just another example of something that I'd like to start moving the project in the direction of, because we're kind of out of the scope of what's in this part of the presentation. So maybe I'll just take that off for right now. But yeah, this kind of takes us in this direction of lots of interesting stuff that we can do with these documents, and kind of brings us back around full circle to one of the points I was trying to iterate early on, which is that Oz has had a hard time sort of marketing itself and explaining to people what it actually is that it does. So one of the ways that I've framed this kind of set of features, the Clojure, Clojure namespace as a notebook kind of idea, is by talking about Oz as a scientific document processing tool, which is accurate and very general, but also does not do a good job of conveying to people the idea that, hey, actually, this is kind of a notebook environment that just operates on plain Clojure files. Because that is really the spirit, or that's at least one angle on what the spirit of this functionality is, right? But there are many other ways to look at it as well, right? Once you look at it from the perspective of, again, producing Marginalia documentation from a set of source code, that's something that is sort of related, as you can kind of see, right? And maybe does fall more into the broad category of scientific documentation, but which kind of obscures some of the other ways that that this tool can be used. It makes it less clear that, again, it has this use case as a sort of notebook like environment. So we're kind of reaching the point now where, again, my presentation has sort of reached its closing point. But to kind of cap things off, what I'd like to do is just kick it off to all of you to see, what of this do you have questions on? What of this would you like to see more or to learn more about? I have I have a project set up so that I can demonstrate some of this new stuff, but I'd like to kind of take a step back because I have no idea how much of that has sort of sunk in or how many questions folks have. So hopefully this is a good place to segue a little bit.
Beautiful. Thank you so much. There was a little question at the chat. Maybe I'll read it.
Okay.
A question by JF, who is here. JF asked, I see that Vega Lite is based on parts of D3. Can you do a basic comparison with the D3 and where they differ? Thanks.
Yeah, I won't do any live coding comparisons of them, but my D3 is pretty rusty. But yeah, to give you a sense of the relationship, Vega and implicitly then Vega Lite do use D3, but my understanding is that it's primarily for some of the underlying math that it does in computing layouts and stuff like that. So a lot of the actual logic is implemented from scratch. And specifically, I believe both projects are implemented in TypeScript. So I think for a while it was just vanilla JavaScript, but they've since moved to TypeScript. And yeah, so hopefully that answers the question. It's mostly kind of implementation details. I think in one prior talk, I erroneously stated that that Vega actually just compiles the specifications down to D3, and that's actually not correct. Vega is doing its own kind of scene graph thing, and has its own kind of data flow model and everything else. So it's really just for kind of incidental pieces that it uses D3. But as far as the power, I guess I can touch on that side of it as well. Yeah, I mean, again, it's been a while since I've written any D3 by hand, but like D3 is very, I mean, you can really drill down and do a lot of very fine-grained things with D3. I would say that the goal of Vega is to be maybe not quite as general, but darn near. I mean, my impression has been, you know, to the extent that there may be some specific features that that D3 supports that Vega does not, but Vega is really trying to capture a lot of that kind of same level of expressiveness. So Vega Lite then, as again a more kind of high-level abstract wrapper around Vega, is really trying to kind of change the leverage dynamic. So the kinds of things that you can do with a very small chunk of Vega Lite would take quite a bit more work with vanilla D3. In general, I mean, something simple might be, you know, maybe not too uncomparable, but where Vega Lite gets really powerful is when you're wanting to do things like take two plots and kind of stick them next to each other, or take some data and kind of split it apart by some property and have that kind of layout in a series of visualizations. This grammar that it has, that it kind of inherits from the grammar of graphics, which inspired ggplot and other frameworks, it makes it able to express very high power things very rapidly. And so it's exceptionally good for prototyping and for, you know, as a data scientist, day to day, just wanting to look at data and, you know, explore it, get a sense of it, and to build interactive, you know, dashboards to kind of facilitate that exploration. It's really, really phenomenal. You can do things with it very quickly that I think will be a lot harder to do with just vanilla D3. That even been said for Vega, where it really shines is if you're trying to do something much more nuanced and want control over all the variables of rendering and so on and so forth, then Vega Lite can do, I mean, almost anything you'd possibly want. I actually saw someone build, what did they build? They built Tetris in Vega, if you can believe it. So I mean, if there's anything I can, you know, anecdotally present to you that that should convince you that it's an extremely capable and flexible language, it's that, yeah, they were actually able to, someone was able to build Tetris with it.
Wonderful. Yeah, Christopher, can I say something?
Sure, yeah.
Yeah, so I think it is kind of important to say, because maybe Christopher wouldn't say it this way himself, that Oz has been so important to us in the last few years, not only in like inspiring other projects, where, you know, many of the relevant other projects has been just really following the path of Oz, literally. Also, just being there as something that just works, where many other projects took the time to define themselves experimental. Oz has been there to support the needs that were actually there and allowed something that was just working. And I remember many sessions where people new to Clojure were just saying, yes, that thing is working for me and it is easy. And that matters so much, and that is so difficult to make. And all this idea of live reload experience, it is actually a difficult problem. And, you know, on some of the other tools we have been experimenting with, we just decided to try it following Oz and then drop it, because it is just difficult to make it work in a robust way. So just like a big thank you for Oz still being there. And I think we haven't talked about some of the other things it is capable of, like just allowing you to do a static website in a way that is robust and works and like very flexibly. So yeah, thank you so much, Christopher.
Yeah. Thank you so much. I really appreciate those kind words. Yeah, it's great. It's great to get that kind of feedback from people, because again, you throw this stuff out and you have no idea whether anyone's going to use it, or whether everyone's just going to think you're kind of crazy, or what's going to happen. So yeah, it's been great to see folks take it and use it. Yeah. So are there here? Let me open the. For some reason I'm having trouble looking at the chat. But any more questions here? With Vega improves the understanding. Yeah, some notes from Ryan here, which I can read. So D3 to Vega Lite are definitely layers. Layers though. I found my effectiveness with Vega Lite improved as I got to understanding the underlying enter, update, exit model that D3 is built around. Yeah, interesting. So yeah, there is for those of you who have used D3, this will probably, you know, ring some bells. So this enter, update, etc. sort of API that D3 has does map very naturally to the encoding aspect of the Vega Lite visualization specifications, if you will. And so yeah, once you kind of understand one, it can help you build intuition for the other. I think what I really like about Vega Lite is, in contrast with D3, certainly once you understand again this API, the enter, leave, etc., it's graspable. It's, I mean, it's something you can attain. You can get your fingers around, or your head around. But I just love the declarative aspect of Vega Lite, being able to say, you know, here's the data. We're mapping these properties to these attributes. I mean, you know, if you blur your eyes and move things around, you know, you can kind of make it look the same. But the just static nature of it with Vega Lite, I think, really just underlies how declarative it is. I mean, if D3 stands for data, what is it? Oh shoot, declarative data. Who remembers what it stands for? I'm pretty sure declarative is in there, right? So, you know, if D3 is supposed to be declarative, I mean, what kind of stronger step in the direction of declarativeness can you take than to actually just make it a data specification? Yeah, no, you know, that's sort of the be all end all there. Yeah. So, did anyone else have questions so far about anything?
Could you tell a little more about static rendering, about this option of creating a website with Oz?
Yeah, sure. So the basic idea, and I can actually give a demonstration. Hold on a second. Oh shit. Okay, here we go. Okay, so so I can go ahead and share screen with you here. Let's see. All right, I probably need this a little bigger, but let me see here. All right, so this is a very bare bones. I mean, basically, like, was start a deps.eden, and this has Metasaurus version 2.0.0 alpha 1 path source.
Christopher, there is a little sound problem where you're typing. So yeah, maybe type and then talk. Sorry for this. Yeah.
Yeah, no, thanks for reminding me. I have I have one of these mechanical keyboards, so it's, sounds like a machine gun's firing, and so I have a desktop plugin that silences my microphone when I'm typing, but it ends up sounding pretty weird when I'm actually trying to talk. So thanks for catching that for me. But hopefully that's fine now. You can hear me talk while I type.
Yes.
Excellent. Cool. Thanks. So all that we have here, and I'm going to comment this form out. It's not really important right now. All that we really have here is just a namespace that we're calling test, and we're requiring the oz.core project as core, or namespace as core, excuse me. And we're going to run this oz build function. So oz build is kind of the main entry point if you're wanting to build a static site with oz. Now, by default, it does fire up a live view of whatever it is that you're going to be editing, whatever the input files are for this build process. But that can be turned off if, for whatever reason, you just want, well, yeah. And as an example, you might want to run this as a kind of standalone command line interface where you just want to build the files and kind of forget about it, not view them for whatever reason. If you want to do that, that is possible. Incidentally, a lot of the core functionality here, this hasn't happened yet, but one of the things I want to do before taking this out of 2.0.0 alpha and to having our first non-alpha release in a long time is to get it so that that's a little bit smoother. Mixing up my thoughts here, to get it so that we have a command line interface built into the tool so that you can, or potentially a set of aliases or whatever that you can use to either build input files or just to view input files or to whatever the case might be. So anyway, to start this, we run the oz build function, and this takes, can show you the signature here. It takes one required parameter, which is a vector of build descriptions. And each one of these build descriptions has the following set of keys. So from, what path are you building from, to what path are you building to. And these can be directories. So if you map from directory to directory, all the relative paths will sort of map in relation. A template function, which can take some hiccup content and return new hiccup, kind of doing potentially whatever you want with it. There are some caveats here with this new with the new system that has been worked out here, which hopefully we'll get to. But some other kind of outpath function. There's some other kind of parameters here to format if you want to, if the extension is for whatever reason not getting the right output format for you, you can set to format manually. You can also use a function form of that. Probably going into more detail than I need here, but actually one final one that is definitely worth mentioning is as assets. So the fact that, yeah, to take a step back here, as I said, build takes a vector of build specifications. So one of the things that makes that, well, one of the reasons it does that is because I would frequently find in the past when I was trying to use any effectively static site generation tool, that it was really hard to kind of to specify that I wanted one set of files to build differently than another, you know? So the kind of common case here is if you have blog posts as part of your website, you might want to render them differently. So if you look at, I think it's Jekyll and I forget which other ones I've tried, but you know, there are a number of these static site generation tools that I think Cryogene also is in this category. A number of these kind of static site generation tools will build static sites for you and have some amount of control over which files get processed how, but it's always been a little bit more limited than what I've wanted. And so I mean, in particular with Cryogene, I found that you could style like blog posts specifically differently, but not other pages. So if you had like an about page that you wanted to style differently from your index.html, then I mean, you just couldn't, it didn't have a lot of flexibility for styling different sets of input files differently. And so one of my goals with Oz, once I kind of started moving into this direction of static site generation, was to think like, how can we get something that's just very simple, that it gives you all the control you need to say, you know, this set of files gets processed this way, this set gets processed another way. And my answer to that was to have this this vector of build specifications or build descriptions. So we can have one set of files coming in from this notebooks directory and sticking that stuff out to build. But if, for instance, I have a bunch of images or style sheets or whatever, stuff that doesn't actually need to get processed, really just needs to get passed through into our output directory, I can use this this as I think it's as assets. Yeah, as assets key, and set that to true. And now everything, you know, if I had an assets directory here, everything in the assets directory would be treated as an asset. It wouldn't be processed as Clojure, or, you know, if it's JSON, it's not going to try to interpret it as hiccup or something silly. It's just going to push that stuff straight through to whatever output directory you specify. If, for example, we had blog posts and we wanted to style them a little bit differently, maybe maybe include a menu bar that or, you know, menu sidebar that shows you other recent blog posts. You could put blog posts in from here, and then, you know, maybe you're putting this out to like build blog or something, and then we don't want as assets, but we might want to use our own template function then, and then that would go here, and you can take your pickup and do whatever you want with it. You know, wrap it in a thing that gives you a menu, and, you know, and then after that does the rest of the hiccup. I'm not going to try to demonstrate that right now, because actually it broke in some of these recent bits of updating that I've been doing. But what I will show you is just the basic experience here of the live code reloading. And we can actually see then that not only will it visualize the specific file that we're going to be editing, but it's also going to be compiling it out to HTML, and we can test that out. So, yeah, go ahead.
Maybe it could be useful to just see your blog so that we can have like a visual idea of the, yeah, thanks.
Yeah, absolutely. So my blog is up at metasaurus.com. Yeah, I haven't actually updated the styles on this with the latest, but so the blog here, this is actually just a page, but it leads to all these blog post pages. And one of the things that, right, so it's possible to attach metadata to your posts. And one of the things that this template does differently is it automatically displays the title, metadata, and published at, and lists of tags that you might apply. And this is stuff that I wouldn't want on the rest of my pages, right? I really just want this on the page that's going to be rendering the blog. So to run, does that, I think that answers the.
Yeah, thank you. It helps. Thanks.
Yeah, no, thanks for suggesting that. So yeah, now that I've explained it kind of in depth here, we can actually just run it and see what happens. I already did, but just to rerun it here. So it's spitting out some log stuff that I need to clean up here. But in short, once we get that running, we really just need to. Oh, and hold on, I need to pull over the. Sorry, just a minute. Too many tabs open here. Here we go. Okay. So so the file in question is test notebook. Where is it? Oh, here it is. Okay, great. So here we have a Clojure file. That I can save. And as soon as I save it, again, all of these comments are going to be processed as Markdown, and the code is going to get evaluated. And again, it's going to be evaluated in parallel when it can, so asynchronously. And one of the things that's really interesting about this is that, so let's say I define a, or let's do like a do block, and then system sleep 1 second, or sorry, thread sleep. I don't know why I always do that. Thread sleep for 1 second. And then we're going to define something. So we're going to define some var, and we're going to set it equal to, hello world or something. And then, yeah, and I think that should be fine. Oh, I should have thought about what I was doing. Okay, I'll tweak that in a second. So now let's say that I want to do something with that var. So maybe I'm going to just print line some var, or here, let's see. Maybe I'll do it. Maybe I'll do this. Print line hello some world, I guess. So and I'm gonna tweak this this time here to get this block to rerun. So notice what happens here. Oh, it was too short. Sorry. Let me tweak this a little bit. Okay, so let's set it for 2 seconds so we can see what's going on here. So notice that when I save, both of these blocks start running. There's a status indicator there that shows that the blocks are running. And you'll see that the form below doesn't update until the one above it updates, right? Which is sort of what you'd expect, right? We're defining a var here, and then down below we're printing from it. So we'd expect that this form doesn't run until the form that actually defines it has has run its course. But to see that this isn't just blocking all downstream forms, we can do something silly over here. So I'm going to just add some numbers, and why not? Let's set it up to 4 seconds. So now you'll see this is finished, and these are still running. And one of the things that's worth harping on here a little bit, because it took a little while to build, if nothing else, is that right, we're not just in parallel, asynchronously, whatever, computing all of these blocks and compiling them to Hiccup or HTML, and then sending the whole thing over to the client anymore. This is one of the things that, well, yeah, is one of the reasons why it took me a really long time to sort of think my way through how I wanted to approach this kind of next phase of updates, this kind of next phase of the project. And it's because I recognized that there's just a lot of situations that I would find myself in where some code had broken, and now like I literally can't see anything in my notebook anymore, right? Just kind of a terrible error handling experience that comes from that. And being running a bunch of computations or building visualizations and stuff, again, all that kind of stuff, and having to change just a couple of paragraphs of prose, but then having the whole thing re-render, right? Getting it set up so that as these forms finish computing, those changes to those individual forms are streamed asynchronously, and the document, each kind of component of the document, can update asynchronously as the results come in. This was one of the core kind of design components that I really wanted to make sure made it into this next this next iteration on the vision, because again, part of our whole goal here with Oz and with this whole kind of notebook namespace as a notebook kind of experience is that we're really trying to bring that like level of flow to the data science community that we get with something like Reagent or with Reagent and Figwheel or Shadow. And I think this is a pretty nice step in that direction. And to kind of illustrate that, what I'm going to do is throw an error in here. So notice now that so we're okay. So yeah, we hit the error now, and we have a stack trace. The downstream form did not run. That was aborted because there's unmet dependencies. Now I can click here on dependencies, and oh, it's wrapping. I need to adjust the styles here. But so this is the block ID for the form that stopped running, and you can see there's a little status indicator there. I can click on it, and it'll actually take me up to the form that stopped running. So this seems somewhat trivial in this particular example because the form is literally like one block above. But you can imagine in a larger file where you're doing a lot of work and all of a sudden something stops working, the ability to really quickly, in whatever didn't run that you thought was going to run, to be able to go into the dependencies and click through and figure out, okay, where are things failing? That I think is potentially really powerful. And I mean, I've only been this has only really kind of looked like what you're seeing right now within the last week, and so it's still kind of early days, but so far it's been a really lovely experience having this kind of dynamic feedback as I'm interacting with my namespace.
That is amazing. Is it a good time for a short question?
Yeah, please.
PPPP at the chat is asking, why use UUIDs for blocks instead of SHAs?
Yeah, it actually, well, let's see, what is it doing? It's using, it is using SHAs effectively. They're being represented as UUIDs. So it's using the hash library, spelled HASCH, which Christian Walbach authored and published. I guess it might be under the Lambda Forge umbrella, I forget. But it is, the reason I use that specifically is because it's designed to work, to give you the same hashes for both Clojure script and Clojure, and between versions and so on and so forth, right? So it should be a reproducible hashing scheme, which is why I'm specifically using that. And I could have had it spit out, a more traditional, base 64 string, but I kind of like UUIDs, so there's an option to spit out UUIDs, and that's the direction I took. Yeah, hopefully that answers that. More of a, yeah, we could switch. I mean, we can maybe even make options if folks have a good reason to do so. But Yeah, any other questions? No? Okay, cool. Let's see. So yeah, I guess the next thing to show you would be that indeed, yeah, that indeed we do get output HTML files here. And so this one, you can see some of the styling hasn't quite come through. Again, this is a work in progress. Like I said, no parentheses were harmed in the making of this this presentation. But you get the basic idea here, right? There's yeah, there's a lot of code changed. And so there's going to be a little bit of a rough patch here for a little while we sort out bugs and regressions. But this does at least prove that, right, it is building out the HTML.
And it is actually building HTML, right? Not just a state of one React component, but actually HTML. And that matters for building a website.
Yeah, yeah, absolutely. So this is good for a number of reasons. One is that when you build a static HTML file like this, for content to be able to find its way into web crawlers and you know, for indexing websites, etc., having the actual HTML just there is really valuable. That's great for SEO. But it's also, it kind of puts us in the right direction as far as targeting output types that aren't, you know, have not been implemented yet, but which are hopefully close to, you know, near on the horizon. So specifically, one thing I've been wanting to do for a very long time now is get these, you know, this Oz content to spit out to PDF format. So we're already, I mean, we've got a lot of the work done, really. It's kind of a matter of just putting the final pieces together. Right now, what the embed process does is when it's sending the visualizations to the client, it can just send the Vega Lite specifications kind of for the live view, can just, you know, render them using Vega or Vega Lite. On the static compile side, there's kind of two different pathways. One is using the npm, well, that is to say the Vega CLI tool, which you can install from npm, and so that's just a command line interface implemented in Node using the Node Canvas API, which will allow you to draw either PNGs or SVGs in, you know, as static images that you can embed in your HTML, and you can do that such that you still attach the JavaScript necessary to take that container with the static image in it and activate the live interactive visualization if it's interactive. But the advantage of actually putting that static file in there is that now if you want to take that HTML file and convert it to PDF using an automatic tool that just does that, or if you're, again, in, I don't know if you've tried putting things up in Dropbox, but you can put an HTML file in Dropbox and it will actually render it for you, but it won't run the JavaScript in like the preview. You can obviously download it and open it in your browser, but if you're trying to share a document that you've been working on with some people, it's really nice to be able to just use that preview view and have it render all of those images in line. And the same goes for if you're spitting content out to something like GitHub, where you want those, you know, it's not gonna render the JavaScript for you, but if you're able to embed an image, then, you know, you can be inserting data visualizations into kind of a wider swath of output files and contexts.
Great.
Yeah.
Can I ask about parallelization and all this multi-threading situation?
Yeah.
How
absolutely.
difficult was it, and why was it difficult? I guess
Yeah.
one important thing here is this feedback that allows us to see what is happening, because otherwise the user can be confused, right? About,
Yeah.
yeah.
Yeah. So the parallel evaluation wasn't tricky. In fact, once you solved the dependency problem, I felt like there's kind of a nice solution which pops out of the woodwork that, I mean, yeah, I mean, it is almost as nice as doing what I think Clerk did, which is just using, what's the library? Sierra's dependency, ordering. You give it a graph and it'll give you kind of an order of, dependency for the items you have. The problem with that is it doesn't tell you like what things can I run at the same time, right? And so I can actually demo just the small bit of code that deals with that particular problem, because it is kind of it's, I think, kind of instructive, and I think kind of cool to look at. I'm a little bit proud of this solution. It kind of comes down to just a nice application of core async. And let me find the right file here so that I can show you. Where am I? Here, let's see. Oops. So right now I've been doing all this work under the next namespace, following kind of the next pattern. Let's see. So I think I can find it by for dependencies. So here's some code where we're inferring dependencies. I'm not going to go into this in detail, but this is where infer dependencies is where that's actually happening. You know what? Let's look at, oh, right. So complete, what's the function name? Oh, complete results. There it is. Complete results. Okay. So here's where this all kind of comes to a head. And let me make this bigger so you can properly look at it. Yeah, so this function, evaluate block, is kind of the core of what's doing the work right now. And I'm going to go over what it's doing right now, because I think it is kind of cool. And then this is actually kind of a nice segue into describing the next thing that I'm working on, which will really kind of complete this set of functionality. And will also kind of is a nice segue for me to answer the other question of yours. This was like, what made this hard, this asynchronous display side of things. So what we're doing here is, oh, keyboard's acting up. What we are doing here is we're creating this initial block evaluation object, which is just going to kind of contain the state that we need to run things. We're building a map of dependency channels for each one of these dependencies. And let's see, where is it? Yeah, so this particular, whoops, sorry. Right, so this particular value dependency chans is coming from, we're keeping track both of a vector of all of these hash IDs, these block IDs that we've been computing, which incidentally, kind of, I think pretty similar to what Clerk is doing, if I understand correctly, is computing hashes based on the actual structure of the form itself, as well as the hashes of everything upstream. That is to say, all the other forms higher up in the file that that are dependencies of the form in question. And right, so we store one vector, which is just the sequence of all those block IDs. We also store a map, which maps the block IDs to results channels. And these results channels are specifically async promise chans. So I don't know if if you haven't used async promise chans, I highly recommend taking a look at them, because they're super handy for cases like this, where you actually have a bunch of different processes that are going to need to be referring to something that you want to kind of spit out from a core async process. Promise chans are really nice because once you stick something in the chan, like that thing, just like with a promise or a future, like that thing will just kind of continue to be the thing that pops up every time you ask for it. So what we're doing here is, yeah, so we're taking the list of dependencies for this particular block, and we're then using this result chans map to get the corresponding result chans for this block. And down below here, then we're passing those into this complete results function, which there's probably a nicer way to do this, but I was having trouble with this. I did something a little bit stupider, but it works, which is basically just to loop over the channels and make sure that we've taken something from each one, right? And so down here then, by putting this in an alt together with a kill channel, which we need in case, right, this is where things do start to get a little bit hairy. If we have one update going through, again, things are happening asynchronously in parallel, so we need to know that if another one comes in and we haven't finished, we need to stop that one so we don't get weird race conditions and different processes writing out to files in out of order and that kind of thing. There's no guarantees here that that's not impossible at the moment, but it seems to mostly do the right thing. So yeah, so using alts to wait on this kill channel and then all of the dependencies to be completed makes it so that each and every one of these blocks will not run until either the whole evaluation has been killed or all of our dependencies have been satisfied. Now, where I think, so there's not a ton of code here. I mean, a lot of this stuff is just bookkeeping, logging. This is really kind of the core of like, how do you do it in parallel? Well, we kick off a bunch of threads and just wait till everything that is a dependency is done, and then we just run the thing, right? So this really wasn't a lot of work at all. When we go through the analysis for each block, we just look at which vars does this block depend on, and then we figure out, because we've already gone through the those blocks, we know what their block IDs are, and we just cache those for each downstream block that has those dependencies. So this part ends up again being relatively straightforward. Felt like a pretty nice solution. Where things get a little bit trickier is then, yeah, how do you update all of these things? And for that, sorry, that is to say, how do you update all these things in the browser asynchronously? And for that, let me see if I can find where this happens again. Let's see. So there's like a queue. Okay, here it is. So there's two sort of pieces to this. Oh, interesting. Hold on. Okay, that's because it's not in here. Okay, here we go. Yes. Let's see. Okay, here it is. So there's a function in the core namespace called build and view async evaluation. A lot of this stuff is going to get cleaned up and move around. It probably won't live here for much longer. It'll probably go to, a lot of the stuff will probably be congealing under some other namespace at some point soon. But basically what's going on here is we're taking all of these blocks, which are code. We have these map representations of each one of the blocks in the file. And it has the code string for it. It has analysis information, the vars that it depends on. Again, all the stuff that we kind of been talking about from having analyzed the file. And if it's a markdown comment, it actually just processes it into Hiccup immediately, so that can be sent with this initial payload, which comes through with view async doc. So the reason we're calling it async doc is because anywhere that we have one of these code blocks where, again, we're going to try to do this asynchronously, except where we, tell it not to. What it's going to do there is place a token. Let me see, where is, see if I can find, yeah, so so there's this async block view function, which there's a function in on the client side of Oz called register live views. And register live views will let you take a tag. This is kind of like the tag compilers that exist on the server side. If you want me to speak more about either one of these, please, feel free to chat or unmute and ask a question. But what we can do here is basically put in a hiccup node with the tag ozdoc async block on the server side. And we put in that block all of that processed information we have about that code block in the file. So again, the source code for it, the block ID, the dependent vars, et cetera, right? So we send that under this, async block, demarcator. Here on the app side, then, whenever it sees a hiccup form that starts with async block, it just replaces it with this component. So this component, what does it do? Well, this component is, let's see, what is it doing? Here we go, right? So if you're dealing with either hiccup or code, then it's going to be, right, so this async result, that's going to be a cursor into the app state corresponding to the specific form that that this async async code block represents, right? So it's going to be, again, keyed based on this block ID, and we're going to have as soon as the server has that result in, there's a callback that's hooked up so that it sends that along with the block ID, sends whatever results it has, any standard out that's been printed, any standard error, again, any error messages. It will send all of that together with the completion time to the client, and that will get stored in the app state. And this cursor then will react to that once we have those results in. So once we have the results in, then it goes ahead and it displays this. Well, the source view is always there because we read the source in when we create these async blocks. So we always display the source. But for everything else, like the standard out view, the standard error view, the error view, and the eval status, all of that we're going to be getting dynamically once we get those results into the client side. So as you can see, this side of it's definitely a little bit more involved. And just to kind of tie everything in a little bit, again, this is where we're sending that async doc. Here we're queuing a result callback, which for each and every single one of these results that finishes, we're going to be taking that and then sending it to our client. Finally, there's the queue completion callback, and this is this was where things started getting tricky, because I was prior to having peeled it apart in this shape, which actually looks pretty decent, it was just very not clear. Like, okay, so you've got all these intermediate results and you're going to be sending them live to the client, but then when do you actually compile the HTML file, right? And the idea that I had for that was have this separate queue completion callback function, which basically just waits until all of those results have either completed or have been canceled for whatever reason, whether there was an error and so downstream things were canceled or whatever the case might be. But once it knows that it can't do anything more, this queue completion callback will fire, and that's what ends up exporting everything that was compiled to an HTML file. And the final thing that happens here is that we just reset an atom corresponding to the last viewed file, so that the next time we go and try to visualize anything, the next time we either reload the page or save and want to rebuild, the file that pops up is going to be the last one that we looked at, which is sort of generally what we want. So yeah, sorry, hopefully that wasn't too detailed, but gives at least some sense of kind of what the challenges were here and how we've solved those problems.
So just to clarify, so during this process, we do have a certain reagent component, I guess, that is updating and giving us this view that we're seeing updating gradually, right? And then at some point, an HTML file is ready, and we would see that after refreshing the page. Is that correct?
Yes, and so that would specifically be, looking over here, that would be this, right? So this is the live view corresponding to this document, and then this would be the, as you can see, it's a little incomplete still, but this would be that HTML view, which yeah, won't update itself when you save the page, but as soon as that complete callback is fired, you'd be able to reload this, and yeah, you'd get those changes. Yeah,
wonderful.
So yeah, great. So the part of this that's that I'm in the process of implementing now is in recognizing that things are a little bit more complicated than what I've implemented here. So what you're looking at here is all based around the assumption of we see a file change, which is one of the files we're watching, and we want to update that file based on whatever has changed in it. What so far has not been implemented in this, this particular release is that if something upstream, like an upstream source file changes, right now it's not updating anything downstream of that. So you're not going to get view updates if you're organizing your code in a source directory that with functions that you're reusing in different names, different notebooks or namespaces. There's a little, there's friction right now in getting those changes from those source files to reflect in the notebooks that that have them as dependencies. And there's kind of a, yeah, so I only just yesterday actually kind of like really struck upon what I think is the right solution to this, because it's actually kind of a tricky problem. And I think the key for me realizing, well, to lay out why it's tricky, I don't know how many of you know this, but if you try saving a file in Vim, it may or may not actually just modify that file. It's frequently the case that, and I don't know if Emacs does this or not. You guys are all probably laughing at me right now. But at least with Vim, it's the case that with standard configuration and everything, or at least my configuration, it will first delete the file that you're editing when you save, and then do some monkeying around with swap files, and then finally like recreate the file with whatever changes you've. And maybe it's because I have some weird plugin installed or whatever, right? But just the fact that it's a possibility, or that you might run a git command, and all of a sudden you've got a bunch of changes coming in. Let's say you have 20 files that have changed. Do you really want to run this sort of process once for each file? It's probably not going to work, right? There's presumably going to be a certain order that the operations have to happen in, one namespace evaluated before the other that depends on it, et cetera. And so, right. And so, we'd like to be doing things like when a file is deleted, especially if it's like an asset file, but I mean, even if not, right? If some input file has deleted, you might reasonably think that, oh, actually, we should delete the output file that corresponded to it. Maybe it's because we actually moved that input file and we want it to be at a different path now. We don't want that old lingering, target to just be sitting there. We want to have that removed. Well, it's hard to do that if you're trying to accommodate these weird text editors that might be deleting things and then recreating them, right? So so one of the things, what I've started working on here at least is code that what it does is it uses the watchers, the file watchers, to, yeah, so basically it uses a timeout. It's kind of like, I don't know if maybe this is a little obscure, but when I was growing up and would make popcorn, my parents would always, say like the 3-second rule, right? You let the popping start until it's going crazy, and then you wait till you get 3 seconds between pops. And once it's been that long between pops, you know that it's approximately, the bag's approximately done. So that's how I often make popcorn still to this day. Who knows if that's the right number, but the optimal number. But the point being that we're kind of taking inspiration from a similar idea here, or we're doing something similar here, which is to say, let's read from this like update queue, this channel, until we hit a certain time limit, timeout threshold, after which no new changes have come in. Because presumably, unless you're dealing with a computer or machine that's just really slow, then maybe we're going to have some issues and need to have some kind of additional control over these thresholds and settings. But assuming you're on a reasonable machine, you would expect that whatever weird stuff Vim or Emacs is doing to delete a file and then recreate it, it's probably not going to take too long. It's probably going to be in the tens of milliseconds range. Which I think was what I actually measured in one just kind of test case, right? So if we wait at least something like 100 milliseconds between our last update and when we trigger the batch of evaluations that we want to do, then now we can look at, instead of just, okay, a single file changed, and now we can go and analyze and do all the work that was described. But now actually we have to do something kind of one level more meta, which is to say, based on all of the files that changed in this period of time, we need to create something a little bit more abstract, like an evaluation set, which represents all of the individual files that have updated, as well as all of their dependencies, which also need to be updated. And let's see, sorry. So with dependencies, you'd want to make sure that you had evaluated those dependencies and had the latest version. And then with anything downstream of that, that's what you would need to update, right? So if you update a source file that one of your notebooks is depending on, you would expect that notebook to update. There's maybe going to be some weirdness as far as which file gets shown if multiple files are being updated. But I think kind of defaulting to specifically what's in the list of watched files. Something that, something I should clarify here that's a little bit different from what you may have seen with Clerk, for instance. So here, my intention, we'll see how this works out, but my intention is that you only specifically have to watch the files that you want to build into targets. So you don't have to explicitly say like, yeah, this is the source directory. I want you to watch these files for changes. What my plan is just to have it, any file that it sees that's local relative to the process that is, the Clojure process that's running everything, within that working directory, it will assume that you want those files updated, which I think, we can add options to customize this if you have a repository in another directory that you're referencing, using deps.eden, and, or you have a project that's split up into different repositories. We should be able to support all of that, no problem. But at least as a base assumption that most libraries, for instance, you don't need to watch for changes. Really, the stuff that you need to watch for changes or stuff that's in your current directory, stuff in your source directory, your paths. So that's kind of the plan there, is that we'll watch those things for changes, but we're not going to render those files unless you have specifically asked to render them as documentation, or whatever the case may be. So that would, if you want to see that, if you want to get your literate programming experience with the source files, and turning them into documentation, then you just need to add another entry in your build specification vector. So that's kind of the idea there. Yeah. should stop and take more questions.
Yeah, by the way, we have 20 more minutes before the official time. Yeah, and it would be nice if people will like to think if you wish to ask anything. And maybe we leave a few minutes to conclude, and maybe for Christopher to just tell a little bit about the coming talk, if you wish, at the conference.
Yeah, sure.
Yeah, let us see if there are any questions in the thread. Not so much. Can I ask about the multi-threading situation? I guess you're listening to file changes in a separate thread, which is not our REPL thread. And then all those computations, evaluations which are taking place are also not on our REPL thread. So nothing is blocking the usual thread of the REPL, I guess. And then things can be happening there. And I'm wondering, is it something that you like to have that additional like thread of dynamics, or is it not intended to be part of the user experience?
Yeah, that's actually a really great question, and one which I had to struggle with a little bit recently, because I actually wasn't really sure what the right thing to do there was. I wasn't sure whether the right default assumption would be that, and again, this mostly has to do with dependencies. So if your notebook depends on a namespace, do you want to have to manually evaluate that namespace in your REPL in order to trigger the updates to your notes, to your notebook? Or do you want to have to save the file to trigger the updates? And this ends up being kind of an interesting problem, because as it turns out, and we've all used, well, maybe not all used, right? We've probably all used at least doc or source string, or at least source in some way or another, from the REPL, or plugged into our editor tooling to get, right, I've got a configuration here so that if I hit, oh, I don't know, let's find something good here. So like, if I hover over a symbol and hit a certain key command, I can get the source code for it, right? So it turns out that there's no, the source code isn't stored by default on the vars. All that's stored are pointers to where, what file, what line number, etc. The code in question that defined the var is located. So there's actually no good way to just evaluate some code at the REPL and then figure out what source produced that code. So this, the problem with this is that you could potentially build something that, using add watch, you could watch the vars that are being generated in your notebook, and when an upstream var changes, you can have that then re-trigger some computation on the corresponding to each individual notebook that you have, that depends on it. But the problem is you're not going to be able to do that that hashing to figure out, do I actually need to run the updates or not? Because that form will not really exist anywhere as something that you can programmatically access. If you've evaluated it at the REPL, it's not saved in the file. That var metadata isn't going to be able to point to an accurate representation of the var definition. So this is kind of a problem. I wasn't sure what to do about this, but I think that ultimately what it did was it pointed me towards assuming that the way that you're going to update, if you want, I mean, so you can certainly still, the way that I've implemented it here, you can certainly still use the REPL to tinker around with evaluating the forms in either your notebook files or in your source files. But if you do want some changes you've made to be, to trigger a new live view update, or to trigger a HTML page rebuild, those changes need to be initiated by saving a file, because that's the only way that you can get the, again, the source strings that you need to figure out what needs to actually change or not. So that ended up being kind of a constraint problem that, had to be worked through. And there's some, it was recognized that there were maybe some different ways we could go with it. But one idea that I have had, which may make things a little bit more flexible for people who like to kind of tinker around with, evaluating their forms and having that trigger upstream changes, would be to use some nREPL middleware that when you evaluate a form, it actually attaches the source for that form to whatever vars are defined therein. That way, when you could do a thing using watchers that would, when it sees that a var has been reevaluated, it could take the source string that you've attached as metadata, and it could use that instead of having to look at a file for figuring out what needs to change or not. It doesn't. It's maybe more work than it's worth, like right now, given that things. But again, once this other kind of tranche of work that I have in flight gets finished, it just won't be necessary. But I think it's interesting. It may be interesting to explore, because I think that there are a lot of people who, regardless of whether they find value in the kind of live code reloading experience, will want to be able to just evaluate things kind of form by form and have more kind of a piecemeal control over what's going on there. Ultimately, yeah, we'll have to see. That's an experiment that we'll have to run to see whether that's functionality that makes sense to have available.
Fascinating. Yeah. Yeah, so except for the many things on the both streams of chat, I don't see any questions now. Maybe we have 13 more minutes. Maybe I'll tell a little thing so that Christopher can rest for a moment, and people here can think about questions. And then we'll take a few more moments for a few more questions and concluding. So in recent workshops and talks, we were having this thinking that there are some wonderful projects like this one, Oz, which are not only useful, they're also very interesting pieces of code to learn from. And they turn out to be open source, so we can learn from them. And then we thought we could have this practice that we call study groups, where a few of us will meet hopefully every week or two and actually learn the source codes of a few of those relevant projects which are very active, and hopefully become helpful to the library authors like Chris, but if not, at least become in a state where we know more about the tools we're using. So there is this thought, and if anybody wishes to be part of this idea of learning about tools and contributing to them, then it would be nice to chat afterwards, and maybe that could be a thing that will start happening soon. And yeah, we were learning amazing things now. Maybe another question, Chris. How can people help you? What would you hope the community to have to do that would be helpful for this project, if at all? Oh, I'm not sure if we can hear you. Oh, I think you're on mute. Oh, sorry.
Yeah. I muted myself because I was eating chocolate. So sorry.
Perfect.
So first of all, yes, thank you for all of that. That was that's fantastic. Yeah, I'd absolutely love to have folks getting more involved. I mean, first thing is just use the stuff. I mean, again, be gentle right now. It's still a little bit teetering. Again, as you can see, like the HTML file doesn't have all the styling and output that it's supposed to yet. All that stuff will settle out in time. My goal here is to hopefully, hopefully by the end of this week, I'll have these kind of evaluation set changes, which I was describing, implemented, and the full kind of development experience. Well, yeah, that full kind of live code reloading flow as I've described it should be implemented by that point. that having been said, it's probably going to be a while before, or at least there's the potential that it's going to be a while before I feel comfortable taking Oz out of alpha status, which I know it's been literally like 2 years that it's been in 1.6.0 something alpha. And, you know, part of what I'm trying to do with the 2.0 is reflect that the reason it's been in alpha that long has been that I've recognized that there's a lot of hard challenges that, you know, design challenges that I need to solve. And I wanted to leave myself wiggle room with the API, in particular with the, you know, the build API, to make sure that I got it right. And that there's, you know, nothing that's going to surprise people. So that's why I left it in alpha. And I mean, so far, it doesn't look like much is going to break. There may be some subtle changes. I mean, the main one that I can think of is that it used to be the case that because each one of the blocks in a file, in a Clojure file, is being evaluated synchronously, that you're always going to have the exact the exact hiccup that you're going to send to the client before you actually send it, right? And so so the template functions that process that hiccup actually have all of the content that they need to figure out, you know, what things might look like. It potentially gets, right now we're sending, for anything that's going to be asynchronously evaluated, we're actually sending one of these asynchronous blocks that we looked at, which again gets picked up by the client, the app, and you know, does the magic that we looked at, where once the results in, it goes and shows all the content. So that's I don't think that's going to be a problem. I mean, I think most of the code that people would write for their template functions should deal with that just fine. If someone wrote some code that doesn't, you know, that makes some assumptions that kind of break that, then I think, you know, we'll need some options for letting people kind of have an escape hatch to run things synchronously. But yeah, for the most part, my goal is to not break or change even anything unless I really absolutely have to. And the reason I left it in alpha is just to give myself that little bit of wiggle room that I need to, you know, make sure that things look right once all is said and done. So again, sorry for going on a tangent there, but which is all to say that, I mean, one of the best things that folks can do right now is just kind of kick the thing and you know, let me know how it works. There's going to be a bunch of stuff that, you know, is still being worked on here, but there's a lot of feedback that I would find really useful, just as far as, you know, does this API actually make sense to you? Is this like the right way to put these pieces together? And yeah, you know, is there anything missing? Are there pieces here that we haven't put in place yet? So so that's one level. Just use the thing and give feedback. I think is a great way to help out. But yeah, if someone's interested in kind of diving in deeper and wants to pick particular chunk of work to help out with, would absolutely love to be able to collaborate with people towards that end. I mean, you know, I like to kind of point out that when I started this whole project, I didn't start trying to like create a new project. I went to the creator of Vizard to see if I could help, you know, take that to the next level. And again, he wasn't interested in taking it there. And so that's the reason I ultimately ended up forking it. But yeah, I'd love to have as many people as are interested in helping see this vision out, join and make that happen as can be. So so yeah, my goal here is, you know, in the next week or so, I'm going to try to get, again, all the issues kind of moved over into a GitHub project, laying out, you know, the path forward. And there's probably going to be a lot of pieces that are that would be approachable for someone who's kind of looking to get involved in the project. So I'll try to find a tag or something like, you know, good first issue to make it easier for folks to get some onboarding there.
Fantastic. Yeah, I'm reading a question from the chat between all the thank yous. Jean King is writing. Thank you. Yeah, Jean is here. Thank you for all your great work, Christopher. Can you talk about why you think there is so much innovation happening in this space? And maybe a
Yeah.
few words on where you want to take Oz, via Clerk, via notebooks, if those are actually comparable projects. Sorry if I missed this if you addressed earlier. Thanks again. And also at the philosophical level, not feature by feature. Smiley.
Yeah, no, that's great. That's great. Let me actually hold on a second here. Where is okay. Yeah, great. I'm having just wanted to be able to skim that so I can make sure I touch on everything. Yeah, so first of all, the question, first of all, thanks, Jane. That is a great comments and questions. So I think that part of the reason why there's so much innovation happening in this space, again, comes back to, for me, what the origin story of the namespace as a notebook kind of vision really was, which again kind of came from this challenge that Aria put out there, and I think that looking back at that, which, just in case you were in here late, right? Part of the impetus for this namespace as a notebook idea came from Aria, who was working at Imperity at the time, and gave a talk where he was reviewing kind of the data science world in Clojure and pointing out that we as a community that has Clojure script have really kind of stumbled upon, well, maybe stumbled is not fair enough. We have cultivated a environment for development of front-end applications that is just really conducive to flow between the live code reloading experience that we have with Figwheel or Shadow, and the ability to connect a REPL into the running browser process and poke at things that way, the way that Lisp folks love to do. That is, I mean, we all know it. We those who've done the front end side of things have experienced it, and especially those who've also messed with, say, Java, vanilla JavaScript or other kind of front end languages, know that there's just something really special that we have here. So I think, to answer your question, the reason that it feels like there's a lot happening here right now is because it is kind of this interesting intersection where we've realized, oh, right, we've got all of these ideas that we've been applying towards front-end development that have the potential to really bring a lot more flow and productivity to our work as data scientists or people who work with data, people who need to analyze data in the Clojure world. So yeah, it's definitely been interesting to see, though. And I mean, again, it's really cool to be participating in the conference here with Stephen Wolfram presenting, because Mathematica was actually my very first language, right? So for me to have started off in this kind of notebook environment and evolved as a programmer and eventually found Clojure, and to kind of now be coming back around and rethinking what the notebook environment is, has been really kind of fun and challenging. So yeah, again, I'd say that's why I think there's a lot happening right here, right now, is that it's just kind of the right moment in time where we've realized that there's this kind of intersection that we can benefit from. And then as far as where I want to take things, and I think you asked about Clerk and direction long term. One of the things that I really want to give Clerk credit for is, aside from putting together the Beholder file watcher, which I'm actually using, solving some issues with macOS responsiveness, which is really great to have that reusable piece. So thank you for putting that out there. One of the things that I think is most different between Oz, as you kind of see it here, and Clerk, is that Clerk has a mode of, by default, rendering the value that is returned from each form in your namespace as a notebook, which I think has been really excellently done. I think it's been really excellently done. And I was a little bit skeptical at first, kind of because of the pagination issue, right? It's like, well, are you gonna blow up your browser? But actually, I mean, they've done, it seems like from the poking around that I've done, a really fantastic job at that particular part of the application. So having, if you haven't played with Clerk yet, you know, when you evaluate a form, if you have some really long collection that's the, you know, the result of a form, it doesn't try to show you everything. It actually paginates, and you can kind of collapse and uncollapse and scroll through a large collection. I think that that interface is really valuable as a tool for exploration, for digging in, for being able to, again, kind of doing what a lot of us think of as, you know, REPL work, where we're, you know, hacking up some code and checking out the results, writing up the next form, and kind of moving on to the next thing. I think philosophically, where Oz takes a somewhat different tack from Clerk is that, sorry, just a second, turn off my my phone's beeping at me. Where Oz has a somewhat different perspective is, again, coming back to this goal of wanting to be able to be really flexible as far as like what we're doing with this content. And so being able to produce static output as either HTML or, again, soon being able to spit out PDF, that part of Oz's goal is really not just to have a tool for us data scientists to communicate with each other, but for us data scientists to communicate with other non-data scientists. So a lot of the design decisions that I've made around Oz have really been inspired by the fact that in my day job, what I do, and well, this segues into a question that that Daniel had. I have a talk coming up, so if you want to know what I do for my day job, on, let's see, what day is it going to be? On Saturday at, I believe, 9:30 in the morning for me, but we'll see what time for other people, or 7:30, 8:30. Look at the schedule. Look at the website. Don't take anything I say for granted here. I'm going to be talking about the work that I do. So if you're interested in that, please go there. But a lot of my work involves doing data analyses and that result in reports that we deliver to clients or partner organizations that are not, you know, general staff by data scientists. We're writing, you know, obviously somewhat technical content, but trying to make it so that it's digestible by a pretty wide audience. And so there's a lot of different decisions that kind of emerge once you head in that direction. Excuse me. So in particular, I wasn't even sure, I mean, right, so Oz for a very long time has just not shown source code in the output files that you create. And the reason for that is that my primary use case has been producing files where I don't really actually want to show the code, right? I want to show the data visualizations. I want to show, you know, maybe tables of data that I put together, whatever the case might be. But I don't really want to show a bunch of code to some people who, you know, it's just their eyes are going to glaze over, right? So I've got a kind of different use case here. We're producing scientific documentation, but we want it to be really approachable. And so I think for that particular application, you end up with that goal in mind, you end up making a number of different decisions. So in particular, while I think that Clerk has done a really wonderful job coming up with its pagination views and its kind of default rendering of the result values from its evaluations, I don't think that those are the right kind of default representations for producing scientific documents where you're not going to be showing the code, where, you know, we're showing someone a literal like map or vector is maybe not the most user-friendly output to use. So again, focusing on what we do here, which is kind of going back, what we do here, which is only, let's see, where is it? Right, so if we, hold on a second, just to make a point of it here. If we fix this bug, right, we're explicitly printing something out here. So we're choosing to include something in the output of the document by printing it, or by doing, again, we can do a literal vector, literal hiccup vector, and, you know, that's going to be included as well. This is the stuff that we want to make sure is going to be in the final report that we send to someone non-technical, right? And so being able to think about, okay, what's in the version that we're looking at where we want to see the source code, where we want to have this kind of literate programming experience, but then being able to turn that off and have the kind of static output that's going to look really nice, that we're going to be able to send to a mayor or to a civil servant, to someone who's not necessarily as technical as we are, and have them get something out of it. So yeah, sorry, I know that was a little long-winded, but that I think is kind of the fundamental. If there's anything that I can point to that's kind of a difference in philosophy that has guided me towards making different decisions, I think that really is it in a nutshell.
Hey, Christopher, Gene here. Hey, thank you so much. I love using
Yeah.
Oz, and that's such a great answer. That's so helpful.
Wonderful.
Thank you. And
Yeah,
holy
so
cow, 2 hours, 2+ hours. This is brutal. Keep up the amazing work.
Awesome. Thanks so much, Gene. Really appreciate it.
Beautiful. Yeah, Gene, this question and comment, they helped so much to end this beautifully. And we are just a little bit after the official time. So maybe, Christopher, you would like to kind of conclude and say a few words before we stop the recording?
Yeah, I'd mainly just like to say thanks everyone for coming here and joining, asking questions, and taking a look at the stuff and taking interest. I hope that you all try it out and leave feedback, and crossing fingers, get involved a little bit, and help me take this to the next level.